Alright, Chapter 6, Polynomials and Polynomial Functions. The key words of this what is to learn properties of exponents to evaluate, simplify expressions, defining, graphing using polynomial functions, adding, subtracting, multiplying, dividing polynomials, factoring polynomials, expressions, solving polynomial equations. Scientific notation: polynomial, standard form, polynomial, function, leading coefficient, degree of polynomial, constant term, end behavior, polynomial, long division, factoring, grouping, quadratic formula, quadratic form or beaded solution, logic, maximum, local maximum, local minimum. Alright, 6.1 Property exponents. Use the property exponents to evaluate, simplify expressions involving powers. And in the activity of the previous page, you have seen with the multiplying two powers on the same base, you can have the exponents with the true of the power of zero exponents, with the zero exponents and negative integer components, how you can find the exponents means. So 3 to the nth minus 3 times 0 is equal to 3 to the nth plus 0. Properties of the equivalent negative integers would be 3 to the nth minus 3 to the negative nth equals 3 to the nth minus nth. 3 to the nth times 3 to 0 is equal to 3 to the nth. Simplifying the equation, 3 to the nth minus 3 to the nth is equal to 3 minus 0. 3 to 0 to the power 0. 3 to the nth times 3 to the power 0 over 3 to the nth equals 3 to the nth over 3 to the nth. Divided each side by 3 to the nth. 3 to the nth minus 3 to the negative nth over 3 to the nth equals 3 to the 0 over 3 to the nth. 3 to 0 is equal to 1. Simplified, and 3 to the negative nth is equal to 1 over 3 to the nth. Property of the exponent summarized throughout this book is assumed in any base with 0 or negative exponents is non-zero. Let a and b be real numbers. Let m and n be integers. The product of a m times a nth equals a plus nth power of power. Am to the nth equals am a to the m times nth. Power product ab to the mth equals am times bm. Negative exponent a minus m, a to the negative m equals 1 over am. 1 over a to the mth. If a is not equal to 0. 0 exponent a to the 0 exponent is equal to 1 if a is not equal to 0. Quotient of powers, a to the mth over a to the n is equal to a m minus n is a is not equal to 0. Power of quotients, a over b to the mth is equal to a m over a to the mth over b to the mth if b is not equal to 0. Simplifying expressions. Simplified algebraic expressions contain only positive exponents. Scientific notation is a number written in scientific notation as a form of c times n to the nth, where 1 is less than or equal to c, greater than but less than, and 10 is greater than c, and is an integer where use the numbers in scientific properties exponents help make calculate it easier. Alright, polynomial functions and their graphs. Define graph polynomial function. Polynomial is a monomial of some monomials with real number coefficients. A polynomial in standard form, if the term is written in the descending order of the exponents from left to right, such as n to the x fifth times x to the third minus 4x. Polynomial is written in standard form, coefficient first degree, leading coefficient in the exponent first degree. And the exponent first term degree is the polynomial. The term of the no variables constant term, linear function, quadratic form, simplified polynomial function. Summary of common type polynomial functions is below. A 0 degree constant would be standard form f the function of x is equal to k. Linear equation has 1 degree, fx is equal to ax plus b. 2 the degree of quadratic, fx ax squared plus bx plus c. Cubic ax3 cubic function of ax squared, ax to the cube times bx squared plus cx plus d. Quadratic fx is equal to ax 4 times bx3 times cx3 dx plus c. Alright. Graphing polynomial functions. When a graph of the polynomial have look at the graph terms, you also need to know the end behavior, which happens at function f as x gets very large or very small. The end of the behavior depends on the degree of leading coefficients in function. Notice for each graph, the low leading coefficient is positive and the degree is odd. In this case, the function fx approaches positive infinity is positive infinity, and x gets very large. And behavior polynomial functions. Graph a polynomial function on the following end order. Quadratic 1. Even, so we'll start at degree is even, the leading coefficients is positive. You have the function approach approximating to positive infinity as x approaches positive infinity or negative infinity. Degree is even, leading coefficients negative. The function x approaches negative infinity as x approaches positive infinity or negative infinity. The degree is odd. Leading coefficient is positive. Fx approaches negative infinity as x approaches negative infinity. Fx approaches positive infinity as x approaches positive infinity. Degree odd, leading coefficient negative. Fx approaches positive infinity. X approaches negative infinity. Fx approaches negative infinity. X approaches positive infinity. 6.2 exercises. 6.3 adding and subtracting polynomials. To add polynomials and the coefficients, add the coefficients in like terms. To subtract polynomials, add opposite with each of the polynomial being subtracted. You can use vertical or horizontal format. Alright, 6.4, multiplying and dividing polynomials. Goal, multiply and divide polynomials. Multiplying two polynomials, you multiply each term of the first polynomial by each term of the second polynomial. You can use vertical or horizontal format. Special products. Some products occur so frequently that it's worth memorizing special product patterns. You can verify these products as following. Sum and difference. A plus b times a minus b is equal to a squared minus b squared. A square of a binomial. A plus b squared equals a squared plus 2ab plus b squared. A minus b squared equals a squared minus 2ab plus b squared. Cube of a binomial. A plus b to the third equals a to the third. 3 times a squared times b plus 3 times a times b squared plus b to the third. A minus b to the third equals a to the third minus 3 times a squared plus b plus 3 times a plus b squared plus minus b to the third. Dividing polynomials. You can divide polynomials following long division, following over the sum steps of the dividing polynomials. You divide the whole number to divide, multiply, subtract, and bring down. Before dividing polynomials, make sure the dividend and divisors are in standard form. Alright, 6.5, factoring cube binomials. Special product patterns. Sum of two cubes, a to the third b plus b to the third equals a plus b to the second. A third plus b third equals a plus b times a to the second minus ab plus b to the second. Difference of the two cubes, a to the third plus minus b third equals a minus b times a squared plus ab plus b squared. Common monomials. Sometimes you can factor in that monomials. Common all terms polynomial. You may be able to factor resulting polynomial. Factoring by grouping. Some of the polynomials can factor grouping parts in terms of the common denominator with the pattern shown below. RA plus RB plus SA plus SB gives you RA plus AB plus SA plus AB or equal to R plus S equal to A plus B. Solving cubic equations. You can find the if in lesson 353 you found 0 with a quadratic function on the side of the function equal to 0, factoring and solving each factor for x. You use the method of solving certain cubic equations. 6.5 exercise. 6.6 polynomial of greater degree. Goal factors polynomial solving polynomial equation degree greater than 3. Exercise, you will use the graph of 4 degree polynomial model the number of the active pods and airline transport licenses. Shows quadratic formula expression is AU squared plus BU plus C, where U is the expression in terms of X is said to be quadratic form. Factors techniques studied in Chapter 5 sometimes be used in factors such expressions. Solving polynomial equations. You solve the quadratic and the cube equations. You can use the same technique with the polynomial equation of the greater degree. Fundamental theorem of algebra. Polynomial function degree. It has an nth solutions. The polynomial function may have a repeated solution which appear more than once. The function x to the fourth plus x to the third minus 2x squared equals x squared plus x1 times x plus 2. And the x is equal to 0 appears twice. And x plus 1, x1 plus x minus 2, x0 appears twice is a repeated solution. The function fx plus 4x plus 3x minus 2x has a degree of 4 and 4 real solutions, as you can see in part B. Example 4, some solution of complex number. The result was provided by a German mathematician called Friedrich Gauss, 1777 and 1855, stated formally in the box below. Fundamental theorem of algebra. Function of f is polynomial degree numbers. As the polynomial degree number is greater than 0, then the equation for fx equals 0 has at least one root in the set of complex numbers. Corollary, if the function fx polynomial degree number is greater than 0, then the equation fx is equal to 0 exactly. N solutions provided each repeated solution is counted individually. 6.7 modeling polynomial functions. Goal: use polynomial function modeling, finding maximum minimum value in real life situation. In example 3, we use polynomial modeling maximum value box of rectangular sheet cardboard. Local maximum, local minimum. The y coordinate of the turning point of the local maximum of the function if the point is higher than all the nearby points. And if the y-coordinate is the turning point of local minimum of the function if the point is lower than all the nearby points. Turning points of polynomial function. The graph of each polynomial degree and the nth number has the most of the nth number of polynomial degree function number minus 1 turning points. If the polynomial function degree number is distinct real zeros, then the graph has polynomial degree numbers nth minus 1 turning points. Polynomial models. In real-world model, a local maximum graph often indicates the value of the maximum quantity being modeled. Chapter 6, Review. Chapter Summary and Review. Scientific notation. Polynomial standard form. Polynomial coefficient function. Leading coefficient. Degree of polynomial. Constant term. End behavior. Polynomial. Long division. Factoring. Grouping. Quadratic form. Repeated solutions. Local maximum. Local minimum. Chapter 7, Power, Roots, and Radicals.